Okay, types of instances. So there's a lot of types of instances that you can use. Their CPU, and sorry, with each instance type, you can have different number of CPUs, memory, storage, and the amount of networking. So this is a very important question when you get down to somebody asking you, okay, what type of instance should I use? Again, anytime you want, you can change it, but when you're starting to think about it, you should be aware of what kind of questions to ask. How is your, are you expecting to use a lot of storage? Or are you planning to use a lot of CPU? Is it something that requires a lot of network throughput? Like, are you sending, large files, or is there a lot of bandwidth? Is it a memory intensive application? So these are the questions you can ask. And based on the answers to those questions, you can help decide what type of instance to use. Okay. And then we're going to look at instances in two different ways. One, we're going to look at it in terms of pricing. How do you price instances? How do you optimize your pricing? And then we'll look at the other piece, which is probably more relevant to what you might do on a day-to-day basis, which is how do I decide which instance to use based on how my EC2 instance is going to be used. All right, so here are the pricing models, all right, that you have in AWS. The first is on-demand instance, and this is how AWS started. This is what happens most of the time when you go into AWS and you go to the console. You start up an instance, it's just on-demand pricing. And we have details in the next slide, so we'll get to that. But that's pricing per hour, per second. You pay for what you use. You can also get reserved instances, and you can say, okay, I know I'm going to be using this server for the entire year. Why do I want to pay per hour pricing when I can get a discount if I'm going to commit to 1 year or 3 years? So you can reserve an instance, and you get a much lower price. Okay. Spot instances are interesting. To be quite honest, I've actually never used a spot instance in any practical scenario. There are very specific use cases, but a spot instance is based on you trying to negotiate a price down and get a low price and use instances only when that instance is available at that price. Then you've got dedicated host and instances, and there's a difference between dedicated host and dedicated instance, and we'll talk about that. And then there's savings plans, which are related to a customer committing to spending a certain amount of money. So if you say, the difference between reserved instance and savings plan, here you reserve an instance, you say I'm committing to use an instance for 1 or 3 years. Here you commit to say I'm going to commit to spending, I don't know, $5,000 a month, and based on what you're committing to use, you get a discount. Okay. All right, so let's talk about on-demand. You're going to pay for, either per second, and the Linux, Windows, SQL servers, and Ubuntu instances, you pay by the second. Everything else you pay by the hour. So, if you're paying by the second, if you use it for less than an hour, you just charge for exactly how many seconds you've used it for. Everything else, if you use it for less than an hour, you get charged up, the amount of an hour based on the fractional amount of an hour that you use. So it rounds up to the nearest hour. There are no commitments. Whether you're paying by the second or by the hour means you can use it for a day, you can use it for 30 days, you can use it for 15 days, you can use it for however long you want. And you don't have to pay anything up front. You get billed at the end of the month, and that's when you pay. And again, want to emphasize that you can increase or decrease your compute capacity whenever you need to. So typically on-demand instances are going to be used um, when you know you don't have, when there's no reason for you to commit to a long-term use. You're really using it maybe for R&D, or you're using an instance every so often. You're testing something with it. That's really the ideal scenario in which one use on-demand instances. And you've got applications with that essentially can't be interrupted, right? And we'll talk about that, and that's really making a comparison to spot instances. But really, the main thing about on-demand instances that they will run as long as you want them to run. They will not just stop. You can and you can stop them whenever you want. So here's just an example. This T2 micro. That's the type of instance. So this is the type T2, and this is the size micro. And we'll talk about that when we get to the purpose view. But this shows you an example of how you compute it. And for 1 month, you're paying $8.32 for this T2 micro. Okay, reserved instances, that's where, let's say, okay, you as a company say, we're going to need 20 servers to run our application. Now, why should I pay per hour when I know I can get a discount, and in some cases up to 75% compared to on demand? So I'm going to agree to a year, or I'm going to agree to 3 years. AWS is going to give me a 75% discount, and that instance is going to run for that, however long it will. You pay for it essentially for 1 year or 3 year. Whether you stop it or not doesn't matter. You're still paying for it for that 3-year period. Yeah. And the other thing is you're guaranteeing that capacity is available, because here's the thing about AWS, right? If you remember how I showed you that that hardware is split up, right? Let's just say that all of a sudden, thousands of people came to, I shouldn't say thousands, millions, upon millions of customers came to AWS, and everybody wanted to use this capacity. If you haven't reserved anything, you only get capacity that's available. Now, I've never ever run into a situation where, what I wanted to run an instance, I couldn't get one, but it's possible. So, if you don't reserve that capacity, then you're going to get whatever capacity is available. By reserving it, you're reserving that capacity as well. Okay. So reserved instances, again, what it's used for, typically production workloads, sometimes development or QA might fall into there as well. Although with development and QA, you can shut down these servers. You don't have to use them all the time. So it may not make sense to reserve an instance, but you would have to do a full, cost analysis to figure out if it made sense. But definitely if you've got production workloads, it would make sense to use a reserved instance. Scheduled reserved instances are similar to reserved instances, except you're saying that I'm going to run this instance every day for this period of time, 8 to 5, 12 to 5, midnight to 6. If you want to run something at night every day, you're going to reserve it from midnight to 6. So again, you're using it for less time. So your discounts are going to be less, but you're still going to get some discounts for reserving for a particular period of time.
Can I ask you a question? So EC2 instance, it's a virtual machine, right?
Yes.
Reserving an instance. When you reserve it, are you reserving an actual physical machine, or what are you reserving actually?
No, you're reserving the capacity. So I don't know how AWS does it in the background, but they will reserve some capacity for you. So if you're reserving, let's say a T2 micro, and I forget what the definition of a T2 micro is, but let's say it's one CPU and 2 gig of RAM. They will reserve a virtual machine that has 1 CPU and 2 gig of RAM whenever you need it. It might not be on the same piece of hardware all the time, but you will have that capacity whenever you need it.
If you don't reserve it, you may not have it.
Correct. But that's very unlikely. Like I said, I've never run into a situation where I've tried to run an instance and it said, we don't have capacity. But theoretically, if you don't reserve an instance and you come in and you try and stand up an instance or spin up an instance, there might not be capacity for you. But like I said,
So
that's rare.
practically, it's better for like it's cheaper when you reserve it, right?
Yes, it's much cheaper when you reserve it. But you're paying, if you reserve it, you're paying for an entire year or 3 years.
Okay.
So it's cheaper per hour, but you're paying a lot of money for it. Okay. And reserved instances, you can pay some upfront or nothing upfront. So you have an option as well. So here's an example of what you might do in a production application. So you might, for example, purchase these 5 reserved instances because you're going to need them, but then you have your peak period during 8 a.m. to 8 p.m. So you reserve another 5 instances between 8 a.m. and 8 p.m. because you don't want to run out of capacity, or you want to reduce your costs. So you have 5 reserved instances 24/7, and then another 5 instances that you would reserve from 8 a.m. to 8 p.m. using the scheduled reserved instance. Odd instances, you basically set a target price, and I'm going to go straight to this flow chart because this is the best way to understand it. So let's say you say I want to purchase a instance for $1 an hour. So essentially, based on the capacity that's available, you essentially, the price of those spot instances fluctuates. And so as soon as the price goes below $1, then your instance will run, and you've got your application running on there. But as soon as it goes over $1, it's going to shut down. So you could be in the middle of doing something, price will go above $1 and it'll shut down. Now there's a lot of different options and nuances to this, but in general, once the price goes above $1, it shuts down. Otherwise, it keeps running. So as you can tell, this is good for, if you've got some workloads where it doesn't matter whether it shuts down here and there, you're just trying to keep the price down. I don't know if batch jobs would be a good example, but any situation, testing might be a good example where you have automated tests that run, and if it starts and stops, doesn't really matter to you, it's going to eventually run. This might be a good option. But you're really trying to keep your price below a certain value here.
It matters for the testing. I am an automation tester, and it matters.
Yeah, I think in some cases you're right. But I'm saying, there might be some scenarios where, it's okay if you do testing over a period of time, and so it doesn't matter if it comes up and down. But yeah, you're right. Generally, if you're trying to get testing done in a period of time and you're running automated tests, you'd need that instance up and running. Might not be the best example.
Sorry for interruption.
No problem. You're right. So spot instances, again, applications that have flexible start and end times, and you're not really concerned if the instances go up and down. Okay, dedicated host and dedicated instances. So a dedicated host is kind of the opposite of cloud computing. Because what you get is you actually get that whole box. Remember how we talked about the whole host is then virtualized and split into different servers. What you're saying now is I want this whole dedicated host. And most of the time, dedicated hosts are used for one of 2 reasons. One is customers are very, very, very concerned about security, and they don't want anybody's stuff running on their same server, so they get a dedicated host. The other reason they do it is because of pricing. software licensing pricing. And for example, Oracle and certain types of software licenses depend on, or they charge you based on the number of hosts or number of CPUs that you have in a host. That and you have to always be running on the same CPUs. You can't change CPUs, otherwise the pricing changes. And so a lot of people who are running those types of software opt to go for dedicated hosts so they can stay in compliance with their licensing. A dedicated instance is you get a dedicated host, but you don't pay for the whole host. You get an instance on that dedicated host. Then if you buy more dedicated instances, you get more instances on that same host. But the idea is you're reserving that host, so to speak, but you're only using a piece of it. Okay, so you get the nobody else will run on that host, but you can't use the whole thing. You're only going to use a piece. Whatever instance you want, whatever size you want, you're going to run that, and you're going to run that on that dedicated host. Okay. And again, dedicated instances and dedicated hosts typically are there for either security reasons or licensing issues, software licensing issues. All right, savings plans. I don't want to spend too much time here, but essentially you're going to commit to AWS, and I'm going to use, $1,000 a month or $5,000 a month or whatever it is. And based on whatever you tell them you're going to use, they're going to give you a discount. And then if you don't use it, you're going to get charged some more, but they're going to give you an upfront discount based on what you commit to them. Okay, this is really probably where we should have spent most of the time. Purpose model. These are the types of categories and instances there are. Burstable, and I don't know if AWS splits it out this way, but I have, because I want you to remember it this way. Burstable, general purpose, compute optimized, memory optimized, storage optimized, and accelerated computing. The ones in yellow, I don't need you to memorize those completely, but I want you to remember them. Because when somebody says, I need a lot of memory, I want you to be able to say, okay, we need to look at R types. Or they say, I need a lot of disk or storage. I want you to say, let's look at D. And here's how you remember this. Burstable, okay? This is the hardest one to remember, but think about this T. Burstable, with the T, burst. General purpose, think about this as like medium. It's kind of the average, medium. M. Compute optimized, C. Compute, C. Memory, what is memory? RAM, R. Storage is what? Disk, D. TMCRD. Again, it's not the end of the world. You can always look them up, but try and commit that to memory. Burstables, general purpose are M, compute optimized are C, memory optimized are R, storage optimized are D. These other ones are not used as often, but you have access to them and you can always look them up, if you need something in particular. Okay, T, M, C, R, and D. In fact, T, M, C, and R are the ones I see use the most. D on the database side sometimes. Okay, general purpose, there's two types, right? There's three types, TMA, but I want to talk about T's and M's. T's are burstable. Burstable instances are instances that you don't get, essentially the performance bursts over time. So you can use, let's say, or your usage can burst over time. But if you use too much of the CPU, it's going to reduce the amount of CPU available to you. So basically it's assuming that your workloads are going to be spiky, that it's going to be low, then high, then low, then high, low, then high. If you have constantly high workloads, that T, the burstables, are going to force you down. Now they've changed some of the options, and they allow you to kind of stay constant for additional money and stuff like that. But think about it as burstable as something that you're going to use when you have spiky workloads. M, medium or general purpose, is when you have kind of an average, you know, you don't need too much memory, you don't need too much disk, you don't need too much networking, you just kind of get away with a average type of CPU. That's when you use the M class. Okay. Compute optimized. So this is when you've got applications like the ones that are listed here that use a lot of CPU. Not so much memory, not so much disk, but they need a lot of performance. And so you're going to use these compute optimized or C class instances. Then you've got memory optimized. Again, memory, think of it as R, RAM, R type, okay? That's when you've got a lot of memory being used. In-memory databases, any sort of memory requirements, high memory requirements, you're going to use a memory optimized. And then storage optimized. This is going to give you more storage compared to more storage per, let's say, per CPU or per gigabyte of RAM than the other ones. Okay. And then accelerated computing, machine learning, deep learning. People use it for high performance computing. You've got GPU processors and things like that, which are part of these types of instances. All right, folks, have a wonderful evening.